about conic sections. And I'm going to make this as short and sweet as possible because I know you guys have a lot of stuff going on at home. There are 4 different types of conic sections. A conic section is formed by the intersection of a plane and a double napped right cone. A double napped cone is 2 cones opposite of each other, extending infinitely upward and downward. The angle of the plane creates the type of conic sections. Label each conic section below. I'm going to label these down here, but you do not have to write any of this. You'll know when I tell you to write something down in your notes, that's when I want you to write something down in your notes. But for right now, just go ahead, watch, and listen. Okay, so I have this really cool link that I found that shows the actual conic sections being created. So there you have a circle. That is what we call an ellipse, parabola, and hyperbola. So it's like a sheet of paper going through the double napped cone. So once again, horizontal, you got a circle. Change the angle, you've got an ellipse. Change the angle a little more, there's your parabola, and a little bit more, there's your hyperbola. Okay, so once again, you've got a circle, an ellipse, a parabola, and a hyperbola. Now, as you notice right here, it says in your notes at the top right. What that means is I want you to write this in your notes, exactly what you see. So right now, go ahead and pause the video and draw this. Make sure you label it horizontal ellipse. Go ahead and pause that video. Okay, so in an ellipse, you have always a center. Right now, our center is going to be right there at 0, 0. And you have a major axis. The major axis is the axis that is longest. So as you can see, you've got an ellipse is kind of like a squished circle. So this one has been squished. So it's like horizontally longer. So that means this is your major axis. The 2 points on that major axis, those are called your vertices. So this right here, this is a vertice, and this right here is a vertice. All right, then you have your minor axis. So your minor axis is the one that is the shorter side of the ellipse. So this is your minor axis. The 2 points on the minor axis, those are called your covertices. So this guy right here is your covertice, and this guy right here is your covertice. Next after that, you have your focus. I have this really cool video to explain where this focus even came from. So to create a focus, you'll end up needing 2 points like tacks. You're going to pull something tight. So normally if you were creating a circle, you would only need 1 tack. And that 1 tack, you would move around and you'd create a circle. Well, an ellipse, you need 2 tacks, okay? And those tacks right there, those are your foci. Foci is plural for focus. So once again, your focus are your foci are those blue tacks right there. And they're always going to be they're always going to be on your major axis and inside of the vertices, okay? All right, so there is a formula to find the focus where it's at on the axis, and it's found by doing c squared is equal to a squared minus b squared. Now, C is your focus, but what is A and B? A is going to be the distance from the center to the vertice, and B is going to be the distance from the center to the covertice. Go ahead and make sure you have everything down, and we're going to go on and write notes about the vertical ellipse. Okay, so you need to draw this in your notes also. Once again, we have a center right there at 0, 0. Your major axis, again, your major axis is the one that is the longest piece of the ellipse. So this is your longest piece. This is your major axis. The 2 points on that major axis, just like before, those 2 points are your vertices. So this is your vertice here, and this is your vertice. Your minor axis is the axis with the shorter part of the ellipse, okay? And then once again, on your minor axis, you have your covertices. And then last but not least, we have our foci, our focus. Remember our focus, the 2 foci are always on our major axes, okay? And the focus is always going to be on the inside of the vertices. Once again, it's the same formula to find the focus. C squared is A squared minus B squared. And once again, A is going to be the distance from the center to the vertice. So A is always on the major axis, and B is the minor axis, from the center to the minor, from the center to the co-vertice. Okay, I'm gonna stop the video right here. We've got another video of examples. So go ahead and close out and find the next video.